Hello guys, my name is Dan Gajanan Napure. I'm a student of IIT Guwahati, DS AI program. My term project is Intelligent Personal Finance Dashboard. Uh, in this uh, in this project, we have noticed the problem that people can easily download their UPI bank statements, but there feels like a need to analyze these statements so that people can actually draw some conclusions and what actually understand their spending habits. For this, we basically observed that we can mainly download our UPI bank statements as in PDF format. We used PDF Plumber library of Python to analyze these UPI statements. Then we use SPACY entity recognition system to categorize some like to categorize payments, and then presented visualizations using visual charges and stuff. This empowers users to actually perceive what their spending habits are and to try and improve upon them. Okay, so basic pipeline of our project is that you upload the PDF statement to our app or web app. The parser will pass this PDF as a I mean, it will group the PDF content in rows. Why it does that is basically if you don't do that, there is a possibility of losing some data as there is like various PDFs. Every like UPI app has different formats, and it we might lose some data. So that's why we group the whole contents in rows, so it becomes easier to keep track of the transactions. Then we split these rows to get our specific required content. Then we parse it. This is where the NER entity recognition system works comes into the play. Basically, we are currently only recognizing like three main categories. Like the first category will be recharge, like recharges that we do. It is usually stored as payee name is stored as a phone number completely. It becomes quite awkward if you load this into the visualization. That's why we change that whole category to recharge. Then there is persons like people, actual people or friends. We actually when we send money to them. Then there is merchants. This is where we faced like we'll discuss it later. Then this classified data is stored as a SQL database, temporary data. Then this data is loaded into our visualizations, where it is visualized with chart.js. There are various uh, charts and stuff. There is also forecasting model which uses cold winters forecasting method to forecast how much spending you will do in future. As you can see here, basically for data, this is our data pipeline. First, we are taking the PDF, then there is row grouping, like I explained. If you ever download the UPI bank statement, you will notice that the whole statement is in tabular form, that there are tables. So, because of row grouping, we get specific rows which we need, and then we can format them further. Uh, Into this formatting comes NLP. We are using inbuilt model of Spacey for this. We are using small model, English model. There was a very particular bug that merchant's name uh, can not be recognized as opposed to like some merchants' names are in Indian merchant names, they cannot be recognized in this model, right? Like they are built on very specific type of data. That data format may not be followed in Indian naming culture. So there was this issue. So what we did was this NLP model basically categorizes the payment payee name if it is a person's name. It tries to recognize if it is a person's name. Like my name is Siddhant Dakure. So it will try to recognize if its name is Siddhant Dakure. Then it will categorize it as a person. If it cannot recognize that this is a person's name, then it will automatically categorize this as a merchant's name. And surprisingly, this works quite well. So that's the strategy we use. Then there is basic our strategy about database. We use like a schema where we are generating a general ID for every transaction. It's we are tracking getting its date, amount, what type of data transaction it was, like credit, debit. Then there is the raw P, which like the person who is associated with the transaction, name of that person, and that pays ID, which we are not actually using. Then we are using NLP classification for these payee names. Then there are few visualization charts there, which will help you understand how your credit over time was, how your debit was. You can also visualize some filters onto your data. Date, there is a date filter. There can be a amount filter. There is also old swinter model, which which uses machine learning to forecast how much will you spend in upcoming month. This can be helpful to get a reality check over your own spendings. We hope to. And there is this is what we inline cascade workflow, like how we are representing this data in our dashboard. Right. We have used class for our application. This for last models starts with main page, which will be um, index.html, where you can upload your bank statements. Once you upload your bank statement here, it go routes to this GF manager dot UI. Here, as you can see, this is the function which look quite simple. Here we are using the species model, English core with SM small model. Basically, the first thing it does, it checks if it's a number. If it's a digit, then it will automatically categorize it as a recharge. If the model, then we submit it to the model. If model recognizes that it is an entity, that is a person, then we will label that a payee as a person. Else, we will label it as a merchant. Then there is this is passing the PDF into words. This is passing amount. What we found out that with different merchants, the format of UPI statement changes. So for GPay, there is a different parser. This is the parser for GPay, and then for PhonePe, I usually use these two apps, so I have built for these two apps. For PhonePe, there is a different type of parser. These parsers have different works, so they have to work separately, and then it does passing for separately. Then this data is appended to a data frame, and at last, this data frame is stored into the SQL database, like temporary uh, for the session. Then once we have this, you will be redirected to dashboard.html. Right. So from dashboard.html, these are the filters. If these filters are active, then these filters are applied on the whole data. If they are not, then it is not applied. Then these filters are applied. So this is the main dashboard workflow. Once this is whole as a whole filters are and everything else are applied, and there is some aggregators are applied. The whole data is sent to main page, that is dashboard.html. This is where the main visualization is taking place. Everything is made into cards, like for very minimal. The design of this site is very minimal, so that we can do like easily visualize, understand it, and it does not get too hard on the eyes. Uh, right. This is implementation of Chart.js. Okay. So this is our personal finance dashboard app. This is deployed on Hugging faces. Uh, so we can choose our bank statement from here. Once the bank statement is chosen, then we can submit it. The PDF will be passed. Then this is the basic dashboard. Uh, Behind the scenes, it has done name recognition and stuff. We can see that this uh, statement is from uh, till June 30. uh, right. This statement is from May 16 to June 13. There are like certain number of transactions, like certain number of debits, and how much amount is credited. Like there is only one or two credits whole account. Then we can like based on this data, the forecaster has forecasted some spending charts. Like the if there is a very short amount of data, then there is bound to be some type of anomalies. Then we can see to how many people this person has like made transactions with over the amount of period. Like they have made three transactions with this person and stuff. Then we can see how many, what categories of people they interact with. Like they have interacted with a person 30 times, and merchant with that like amount of transactions. We can switch to credit and debit here. We can filter by people to people, like how many, like for Siddhant, how much, like okay. So this is the net flow, right? Like they had two transactions with this entity, and these they are reflected like this. Then these are the complete transactions present in database. Uh, we can see it here that there are not many. That's why there is a kind of anomalies here and there. Uh, Also, we can apply these filters to actually change the visualizations uh, as we want. Like this is the outlier, so we don't want this transaction to be there. So we can just input that maximum amount should be 1,000 rupees, and then uh, that transaction if, like filter is applied over there. So that's the whole dashboard here. So that was our project. The key conclusion was we completely developed end-to-end application. We learned how to I learned how to pass these PDFs into tabular data. Then there was entity extraction using SPACY named entity recognition models. We also used some for learned how to forecast the time series data. The some are critical thinking points where like logarithmic charts versus linear charts. Like when building, if we want the charts to look good, then we will have to use logarithmic charts regardless of the like. If we want the charts to look good regardless of the like irregularities in the data, then we will have to use logarithmic charts. But if we want to show the actual data, then we will have to use linear charting. But linear charting can have some differences. If there is a very high value and every value is less, then it pretty much loses the point. Then there is NER domain limitations like name entity recognition. It is I find it found it pretty like limited stuff. I would love to work more on that things, and that is all for my project. Thank you. Thank you for watching.